I just want to be very clear about how I feel about customary to metric conversions and how the school system spends its time teaching students this instead of teaching them the metric system, and how much it doesn't make sense. But it's something we got to do, so let's do it. I am going to go over a brief history of why this is happening, and then I'm going to go over some actual math that is conversions that only Americans, people that live in Burma or Liberia, ever do. Here's a good example of how simple it could be for us to do conversion since it's a base 10 system, the metric system. USA, hey, you know how the metric system is very simple and straightforward? Other person, yes. USA, how about we make it not that way and we'll call it customary. So you can see what part of the world down here is actually spending their time doing this stuff. Uh, it's pretty weird. So it's just how America measures. And there's nothing wrong with that. Red, white, and blue. Here we go. This is a key. Without the key, conversions from your star chart would not be able to be done. So it's interesting that time is spent on doing these types of things, considering the state of Texas is not actually assessing this extent. So we're going to go over how to do this part because they gave you a key, which is basically like your formula chart for other conversions. So spending time going over how to convert from customary to metric and metric to customary, yeah, I don't know. But at least a key was provided. So let's just go ahead and start with a hypothetical situation. And Bob is our crazy volunteer. Thanks, Bob. Uh, Bob wants to run 3 miles, but his coach wants to know how many yards that is. Why? Well, you know what? I don't care because all we do is we tutor Bob. And Bob's asking. So we're going to help Bob. And why would his coach ask that? I don't know because coaches do that stuff and they want to, like, because you're a student, I don't know, you're a student athlete. So the thing to always start with is, okay, what are the 2 units that are being converted? I know that Bob has 3 miles and the other conversion was yards. Okay, so these are 2 numbers that we do know, and then we can go reference our, so we know that miles and yards, that measures length, right? So we can go into the length section. Then we can find out where miles and yards are right next to each other. Miles and yards. Cool, that's what we're using right there. It makes perfect sense that 1 mile would equal 1,760 yards because, um, well, another time, because it just know that it makes sense. America measure. So I'm going to write down the 2 things that we're measuring, miles and yards. The next thing is going to be called a conversion factor. It's the thing we just highlighted right here. It's called a conversion factor. Okay, if 1 mile is 1,760 yards, then blah miles could be blah yards. So I'm going to write down the conversion factor. See, look, we haven't done any math yet. And then I'm going to write down the information that I was given. This is the only number in the entire problem. 3 miles. So I'm going to go 3. Well, what goes in this blank? Well, that's the yards that we don't know. We can go ahead and put a question mark. I'm going to go ahead and say don't put a question mark, but it's going to be a variable. I'm going to use x. It's the same thing as a question mark. You still don't know, but let's just stick to the algebra. Quit talking me into using other stuff. All right, so this is where cross products come in. If I were to set this up as like a proportion, it would look like this. This is just a template that I use so I can sort my information. All right? So I'm going to go ahead and use the proportion because that's going to be the thing that you're using. 1 times x. If I had x 1 time, it would look like that. And it's going to be equal to whatever the cross product of this is. 3 times 1,760. I don't know. 3 times 1,760. 5,280. Oh, wow. Look at that. The problem's done. Skippity. So that's really easy and very weird at the same time. Um, the reason that it came out to be 5,280 is because of the conversion factor of a yard to 3 feet. We took this and did it by 3, so that's going to make this look like the same conversion factor as that. Anyway, 5,280 yards, and that makes sense to everybody when you tell them. Be like, hey man, have you ever done a 5,280 yard race? And they'll go, I have no idea how far that is. And you go, 3 miles? And they'll go, oh yeah, totally. It's a 5K. You run, bro? Okay, so same process. Bro, my dog weighs like 2.5 tons. No joke, bro. Dude, that's like blank pounds. Oh, yeah. So whenever someone does this, they're obviously exaggerating, and that's what makes it funny because you could go, wow, 2.5 tons. That's a lot of weight. That's wow. Okay. You have a really fat dog, and then you do the conversion. You're like, oh wow, okay, that was way too much. If anybody measures their dog in tons, they're lying. So the two things in the problem that we were talking about. So Surfer Dude brings up that weighs like 2.5 tons, and then the other measurement was pounds. So we got to see tons to pounds. We know that's not length. We're not seeing how far a ton is, and then we're going to convert that ton distance into how many pounds away it is. That doesn't even make sense. Uh, we're going to go into volume and capacity because when we're taking weight, it's everything inside of it. Capacity is how much it would hold. So tons and pounds. Is there anything that says tons and pounds? Tons and pounds. Weight and mass? Oh, dang. Weight and mass. How much it weighs. Oh, gosh. Wow, that got weight thrown off. Tons and pounds. What I just did right there was a self-talk about what I'm looking for. Now, I made up some kind of weird answer for volume and capacity, but I did not see tons and pounds here. That means I just went to another section and looked for tons next to pounds. You got to find it. Whenever you find it, that's what you're looking for. So going to the table, we're writing down the two things that Bro Dude said. That will be pounds, tons, and pounds. That's the things that were mentioned, right? And Surfer Dude says 2.5 tons. I'm going to use 2.5. I'm just doing this one a little different because I want you to know that you can put this stuff wherever you want to. I prefer to put the conversion factor in this slot and then put the information I know in this one, but I want you to see that the answer is going to be the same. So I can write it both ways. That's not a problem. 2.5 tons is like, I don't know how many pounds. Okay, so there's X. That looks different than the last problem. So then 1 equals 200,000. 1 ton, or 2,000. 1 ton equals 2,000. See, there's the conversion factor. Now, if I wanted to do it the way I did the last problem, conversion factor, this thing, 1 ton is 2,000. 1 ton is 2,000. And then put the information I know, 2.5 tons. Tons goes up top, 2.5. And then I don't know down here. See, it's the same problem. It's just these two things are flipped. And it still multiplies to be all the same stuff and everything like that. So 1x, if I just wanted one of those, there it is. I'm going to set that equal to 2.5 times 2,000. Well, 2 times 2,000 is 4,000. Half of 2,000 is 1,000. 4,000 plus 1,000 is 5,000. 5,000 pounds. So let's go back over what Dude Bro says and see how ridiculous it sounds with it converted. Okay. Bro, my dog weighs like 2.5 tons. No joke, bro. Dude, That's like 5,000 pounds. Oh. All right, Bluebell, they made a comeback. I didn't think they were going to do it, but they did. And so Monica and I just ate 9 quarts of ice cream, and I'm lactose intolerant, so we won't go into what that's going to turn into. Bluebell takes empty cartons back for a donation, but only do it by the gallon. How many gallons total did we eat? Oh my gosh, this is like a nightmare. This is going to be real painful. Lots of gas. We could say that. Um, so we're going to go through our routine. We're going to read the problem. Just ate 9 quarts. What was the other measurement in there? Cartons? No. Gallon. There we go. All right. Then we go look at our cheat sheet over here because they just want to know if you can read and put stuff somewhere. So 9 quarts in gallons. Quarts and gallons. Quarts. Oh, hey, look at that. It's right there in the middle. Quarts and gallons. Cool. So now I'm going to write down the 2 things I'm measuring. Gallons and quarts. And you can put quarts and gallons since that's what it says in the problem. See, look, I'll change it. Quarts and gallons. But just make sure that when you're writing down your conversion factor, you put the numbers in the right spot. I always like to go with this and then put this information where it goes. So 1 gallon, because gallon is 1 gallon. 4 quarts, I'm going to put 4 next to quarts. Now we look at the problem, because we already used our conversion factor. 9 quarts. I'm going to put 9 with the quarts. How many gallons? Oh, gosh. Okay, so it looks like whenever we're going from something smaller to bigger, what? Okay, so 4 times x is 4 x's. 9 times 1 is 9. Look at that, one-step equation. Hey, why do we do those things? Right now. That's why. For a number next to a variable means... No, what's going on? Why is he doing this? No, please stop. This is not good. No, my pen! Why? Like, seriously, what's happening? What is this? What is this nonsense? Checking for drive updates. You seriously gonna make me restart this entire video? Well, real cute. There we go. Okay. Wow. Sorry about that. That was entertaining for you, but not for me. Okay, so a number next to a variable means multiply, so that means we are doing its opposite, which means divide. Nice recovery. X equals, well, we got 9/4. That's an improper fraction. We could do 9 divided by 4 on a calculator, or we could go, how many times does 4 fit in 9? 4, 8, 2, and then what would be left over? 1/4 gallons. So 2¼ gallons. We'd only be able to donate 2 of them. So no matter what, I mean, you're going to be able to set a proportion. You already know how to solve one-step equations. I'm going to go ahead and throw a curveball on this last one. And this is going to be a double conversion. So I'm going to end up with 2 of these things. Just go ahead and duplicate this. Yeah, I was supposed to move and it didn't. Okay. So, let's read the problem. I set up a football game with ants because I'm incredibly weird. Yes, I know, it's weird. Every yard has been converted into inches. Yard, inches. Cool. I just saw that like I felt like I said 2 measurements. If a normal football field is 100 yards, end zone to end zone, then how many inches should my field be? All right, so 100 yards, inches again. I mentioned it again. All right, so I got to find yards to inches, yards to feet. Oh, geez. Yards. Oh, no. Oh, gosh. All right. So if yards, I can convert feet. Okay, hold on. I can convert yards into feet. Cool. Then I can convert the feet I get into inches. Okay, so I'm going to name that 1, and then this one is 2. Okay, so since I can't do yards to inches, I have to do yards to feet, and then I can turn feet into inches. If I wanted to be real mean to you, I would say uh, I'm on a planet of giants, and every mile is equal to 1 yard. And if I went to Earth, every yard is equal to 3 feet. But I set up one for ants, so how many inches would that be? And you're like, who does this? So yards to inches. Let's start with yards to feet. Okay. And you're sitting there going, what are you talking about? So let's see, 100, or let's start with our conversion factor. 1 yard is 3 feet. And then we have one that's 100 yards. So how many feet would that be? I don't know. So we do our cross products. X equals 300. 300 feet. Ooh, awesome. So this is kind of like our new answer that we're working with for the second part. All right, that was easy. So now we're going from feet to inches. So we know that 1 foot is equal to 12 inches, and we know that we have 300 feet because we just got that, and we have no idea how many inches that is. Cross products. X equals 12 times 300. Oh my gosh, 1, 2, 3, 4, I don't know, 3,600. So your coach, you'd be able to walk up to him and go, dude, like, duh, if you're making 100 yards into inches, all you have to do is have 3,600 of them. Get with it, old guy.